So in this next episode, I want to introduce Ethereum and smart contract platforms. And what I want to try and do is frame the picture as so I think something like Bitcoin, which I talked about in my first episode, is different from something like Ethereum and these true smart contract platforms. And by the end, I will chat on how I think that these two types of blockchains can coexist with one another. Nothing in the video will be related to investing or financial advice. Just going to be going through the technology behind Ethereum and smart contracts and provide some opinions on it. So in terms of topics that I'll be talking about, I'm going to talk about what happened after Bitcoin. So what kind of problems came about and what people were trying to do to solve these problems. Since I think that this can help introduce why something like Ethereum, which is what people call a smart contracts platform, why something like that was built. So I'll obviously talk about what smart contracts are. I'll also talk about decentralized applications. And then I will attempt to give my take on what Web 3.0 and the multi-chain metaverse may be. So after Bitcoin came out, there's two things that I think are important to talk about before I jump into Ethereum. With the first one being that after the Bitcoin blockchain came out, a bunch of people started to learn about this technology and started to build all sorts of things on top of the actual technology of Bitcoin. So a cool example is this game called Satoshi Dice, where you basically used the Bitcoin blockchain transaction to make a bet, and a random generator would basically either give you some Bitcoin as a reward or you would lose the Bitcoin that you initiated the transaction with. So it was like a gambling game, right, where you basically had a dice roll of having a chance to win some Bitcoin. And this made a bunch of people get on the Bitcoin blockchain to play this betting game. But the cool thing was that people kept on tinkering with the Bitcoin blockchain to see what kind of cool stuff they could come up with. And Namecoin is another application that was built on top of Bitcoin that essentially allowed you to own some Bitcoins and give them a name. So that it represented its own new unique currency that was backed by Bitcoin. And I think a good analogy to tokens on the Bitcoin blockchain could be to compare casino chips, where when you go into a casino, you provide some US dollars in cash, and in return, you get this new casino chips currency. And when you go back to the teller, who's basically facilitating the issuance of these chips that are backed by US dollars, you're able to redeem them for the cash you provided. And again, there's a central issuer in the casino that is responsible for the issuance of these chips and the redeeming of the original currency, which in this case is the US dollar. So you do the same with these tokens, where you could create maybe 10 new tokens on the Bitcoin blockchain that were backed by this one Bitcoin. And because the Bitcoin can be subdivided and transferred by the Bitcoin blockchain, it is able to serve as this automated central issuer that is basically handling the transferring and the redeeming of these tokens. And it's using the Bitcoin blockchain as this automated issuer. And you could always verify the tokens by looking up on the blockchain ledger, on the Bitcoin ledger, and see who the owners of these named Bitcoins are. And really, that type of technology led to so many different tokens and new cryptocurrencies being made and sold back and forth on the Bitcoin blockchain. And so the Bitcoin blockchain, just by its design, it allowed developers to build these funky types of applications or new currencies that live within the actual blockchain. And they did this just by taking advantage of how the blockchain was designed and using this native programming language that lived within the Bitcoin blockchain called Bitcoin script. But ultimately, just with the way that the Bitcoin blockchain was built and designed, it wasn't an ideal blockchain for you to use, and write code to build stuff on top of, right? And because its main purpose was really just to be this digital payment rail for the internet, right? And so as people started building different things on top of Bitcoin and more people started to actually plug into this monetary network, there were big time traffic jams. And the network just started getting extremely clogged, and it caused transactions to be either really, really slow or really expensive. So because of this, people started building basically different versions of Bitcoin. And these networks, they attempted to compete with Bitcoin by being faster or being cheaper in different ways. And early on, the way that these engineers were doing this was by doing these things called forks. So things like Litecoin and Bitcoin Cash, which came out after Bitcoin and before Ethereum, these are examples of forks of Bitcoin. And a fork of a blockchain is basically a split in the blockchain network. So if you look here, the blockchain was originally in this light red color, And with a fork, we say that there's now some change that occurs that essentially causes these two chains to be created, right? So it makes a fork in the original chain. So this dark red one could be a continuation of the original chain, and this yellow fork is whatever this new chain is. And that's exactly what Litecoin is. Litecoin is the same underlying code as the Bitcoin blockchain, but they say, hey, let's change up some of the rules that us miners are using to agree on for maintaining this ledger, and we're going to operate under these new sets of rules. So if we look at this slide, the Bitcoin blockchain would basically be this flow of old rules, little squares, and then the Litecoin blockchain would be these new rules, little squares. And after the fork, the blockchains would then just operate completely separately, right? They have their own set of miners who are now agreeing to their own set of rules on, how they're adding blocks to this blockchain. And the old Bitcoin blockchain would just keep going. And so I think of these other new blockchains that came out as essentially being competing monetary networks, right? Litecoin was a Bitcoin fork, but they had some minor differences since they wanted to be a faster and cheaper network. Bitcoin Cash, same code as the original Bitcoin blockchain, but they say, hey, we're going to make the size of each block bigger so that we can fit more transactions in each block. And this just, they did this so that the network just doesn't get as clogged, so things can stay fast and cheap. And although these are new monetary networks, right, like different blockchains, the actual blockchain design was really not changing much, right? So to recap, after Bitcoin came out, not only were people, making these forks of Bitcoin, but the people were also using the blockchain to build all these types of interesting applications. And although the engineers were able to use the Bitcoin blockchain, again, it was not an ideal blockchain, where it can be this multi-purpose chain where you can not only send peer-to-peer payments back and forth, but that you could also build these, tons of different unique applications on. So what was really missing was something that would actually make the building of applications on a blockchain very simple. And not only very simple, but then also giving developers a lot of freedom when designing and building, since the Bitcoin blockchain was actually kind of limiting developers in many ways. And so enter Ethereum in 2014. So Ethereum is a blockchain, but rather than being this chain that's main purpose was to be this ledger that, you can transfer a decentralized currency back and forth, Ethereum sought to be a blockchain where you could also build all these different types of features and applications on top of. And if you haven't watched my first episode where I go into pretty good detail on the Bitcoin blockchain, distributed ledger technology, I'll put a link in the description for you to watch. It may be good to have it just give a quick view, since in this video I definitely talk about a lot of things that are spoken about in more detail in that video in terms of the miners and how the miners are reaching consensus. But to focus on Ethereum here, how it's able to be this blockchain where you could build these applications on top of is by two things. One, having a much better built-in programming language called Solidity, right? And then just also tweaking the overall blockchain design so that it allowed the different wallets that are connected into this blockchain and this ledger to interact in very new ways. And Ethereum is similar to the Bitcoin blockchain, right? But it does have some pretty key differences. And there's two in particular that I want to call out, with the first one relating to how updates to the ledger are being managed, right? And how these miners are actually reaching consensus. So Ethereum, they decided to make the time that it takes to solve that proof of work puzzle that the miners are competing for much smaller. And they did this so that the transactions can be quicker. And Ethereum really made some pretty major changes to the proof of work model, especially just now as the network has gotten older. And I won't cover that in too much detail in this video, since there's really just so much other stuff to cover on Ethereum. But at a high level, it incorporates a lot of these same practices of Bitcoin, where the miners are competing for block rewards, but it just has some key differences so that the blockchain can function faster, right? So that's the main different that's important to call out, right? The fact that the consensus method is different from Bitcoin. But the second key difference between Bitcoin and Ethereum is the Ethereum virtual machine. And so the EVM is a very important piece about Ethereum. And the term virtual machine has actually been around in the computer science space for quite some time. And essentially a virtual computer is something a computer that you can access remotely, right? Almost like a cloud computer. And you can run different computer applications, you can store data, you can basically do anything that a regular computer can do. And so the Ethereum virtual machine is this computer that you can access remotely and lives within the Ethereum blockchain. And this is what allows developers to build really cool applications that can live in Ethereum. And so now that we've introduced some of these key differences of the Ethereum blockchain, and there's plenty more really, I think I'm really just calling out some that I think are important to call out for this presentation. But now I think it's a good time to kind of segue into some of the similarities that Ethereum and Bitcoin share. And so in my first video, to kind of give a brief recap of where I talked a lot about the Bitcoin blockchain and how it's this distributed global ledger that all the miners and all the nodes in the network are working together to maintain, and how the miners are all reaching consensus to add pages into this ledger or to add blocks into this blockchain. And this network, the wallets that are connected into this network are able to send BTC, that's the native currency of the Bitcoin network. And the miners are all incentivized to work together to process all these transactions and also continue to add blocks into the blockchain by competing for the block reward. And so same thing is going on with Ethereum, that same kind of dynamics between the miners. But the main difference is that instead of the native currency being Bitcoin, the native currency for Ethereum is Ether, right? And so Ether is this native currency that we're sending back and forth. And it's also the currency that is used to pay for what is called gas. So gas is what's needed to actually initiate transactions on the blockchain. So just like how you needed to send a tip of Bitcoin to the miners in order to process your transaction on the Bitcoin network, you have to do the same thing for Ethereum. But because the native currency for this network is Ether, we send Ether with our transactions. And this is the quote-unquote gas that's needed to send the miners so that they can actually process your transaction. And gas is also what is used to incentivize the miners to join this network and process transactions, since they can earn fees from mining a block in the Ethereum blockchain. And these Ethereum nodes, they actually aggregate all the transactions that they get in a way that maximizes the amount of transaction fees, just based on the amount of fees that different wallets are sending for their transaction request. And another interesting point about Ethereum is that these miners are not only processing these transactions and updating the actual Ethereum ledger, but they're also responsible for maintaining the state of this Ethereum virtual machine. So if anyone deployed any changes to this virtual machine, this global computer, the miners are also having to achieve consensus on those updates. And so to recap, we have this new concept of a ledger-based blockchain, right, that serves as a value network where you can send Ether. But that also includes this Ethereum virtual machine that is this cloud-like computer that lives within the actual blockchain. And the Ethereum blockchain ends up basically serving as like this database of information for this Ethereum virtual machine. But at the end of the day, for the Ethereum virtual machine to actually work, right, for any computer to work, it needs to have some kind of code or instructions, right, for the machine to follow, or else it just wouldn't do anything. So we need a way to deploy some code, some information or instructions to this virtual computer. And this is where the term smart contracts starts to come in. So similar to the BTC blockchain, right, the Ethereum chain is this open permissionless ledger, right, that allows different wallets to connect and initiate transactions, right? And basically a crypto wallet is essentially, it can be either a software wallet, so like a computer application, or it can be a hardware wallet, like an actual device, something like a USB, right? And basically these wallets, they allow you to have an account on these ledgers and initiate transactions back and forth, and you can hold different crypto assets in these ledgers. But what Ethereum allowed was essentially for these accounts that live in this ledger to be able to have pieces of code embedded within them. And this code is then able to be uploaded into this Ethereum virtual machine that the miners are upkeeping. And this is what allows different wallets on the blockchain to interact with these different code accounts, right? So in this code is written in this language called Solidity, right? And these accounts that have this publicly accessible code within them, this is what we call smart contracts, right? And I say the word publicly accessible, right? Because theoretically, any developer can deploy code to this Ethereum blockchain, which is this public ledger that any wallet can interact with. And so the Ethereum ledger, it ends up having these two different types of accounts, right? The first type is these externally owned accounts. So this is what something like you and I would have access to, right? And then there's contract accounts, right? So the contract accounts, these are the accounts that are deployed into the Ethereum virtual machine, into the blockchain, and are controlled by the actual code that lives within that account. So in these accounts, every time it receives a message, maybe like a transaction request, the code turns on, and the account starts doing whatever it is that the code was written allows it to do, right? And so this is how the Ethereum virtual machine can get code deployed into the virtual computer, right? And because this virtual computer is part of the global decentralized system of Ethereum, any wallet has the ability to interact and make use of this virtual machine and of all this code that gets deployed. And so it really is the same way that anybody can interact with the Ethereum ledger, right? And so when we're interacting with this Ethereum virtual machine, what we're really interacting with is these smart contract accounts. And so a smart contract, one of the first definitions of it, originally referred to a contract that would settle itself automatically, right, through some type of code. Usually when a contract is made between two types of parties, there's always some type of intermediary, right, or third party that's usually involved to serve as somewhat of a facilitator of the contract, basically ensuring that the terms of the contract are met by both sides. That's usually what they're trying to do. And the idea of smart contracts is that instead of having these contracts that are enforced by some type of legal system or judicial system, or even just like some other third party or entity, that you have these contracts that can essentially enforce themselves using code. And that's why we have the term smart contract. It's basically like smartphone, right? And the idea is that if this code lives on this publicly available blockchain, anyone with a ledger, right, can interact with that code. But now the word smart contract, I think means something a little different. And this is the case with a lot of terms in crypto, because the space is so new, things are changing so rapidly. The definitions of things are just constantly changing. But now when people refer to smart contracts, they may not necessarily be talking about some type of code that's facilitating a legitimate contract, right? But rather it's referring to any of these accounts, on the Ethereum ledger that have these bits of code in them that we can interact with. And so it doesn't have to exactly involve a real contract, right, or something that simulates a real contract. It can really be any piece of code that you can add into the Ethereum virtual machine. And this was kind of the vision that one of the main founders of Ethereum, Vitalik Buterin, had in mind when building something like Ethereum, and that was to create something that would give developers kind of like a free canvas to design on, right? And something that allowed big applications and small applications to coexist in this Ethereum blockchain. And so I think that was, maybe a nice little introduction on what smart contracts are. But now to kind of harp on it some more, I'll go through an example of what a smart contract can be used for, right? And I'll basically go through a snippet of a video that I found. It's a great little short video. I'll put in the description if you also want to watch it. But I'm just going to go through a quick part of it. And so for this example, I'll go through what something like GoFundMe does. So GoFundMe is a third party that is essentially connecting individuals who need funds with individuals that are willing and able to provide funds or liquidity, right? And so we see here in this example, this team would like to raise $10,000 by March 1st, 2022. And so as time goes on, right, individuals, they start sending funds into this escrow account that GoFundMe manages. And if the $10,000 is reached prior to the goal date, then the funds are sent by GoFundMe to the team. And so GoFundMe is basically responsible for holding the money and ensuring that it gets sent to the right parties based on whatever rules that this team put in the initial contract. And so the song is kind of the same as in my last video, where theoretically GoFundMe is facilitating all of these digital transactions that are going on, right, between all the different individuals that are involved. And so we're essentially trusting GoFundMe to, one, keep good care of our money in escrow, right? But two, that it will follow through on its commitment to adhere to whatever rules were set in this initial, GoFundMe fundraising contract. And I'm not saying that GoFundMe would ever do something like this, but you never know. GoFundMe could at any point decide not to adhere to those rules for whatever reason, right? And not send the appropriate funds to the right parties. And so the idea is that we replace GoFundMe with something like a smart contract, where we have this account on the Ethereum ledger that has the same rules as the code in GoFundMe, where it will receive funds from different wallets and follow a set of rules that are set by the team that creates the goal of whatever amount of dollars by whatever date. So in this case, I'm going to keep the rules the same of $10,000 by March 1st, right? And so the different wallets, they'll start sending funds to the contract account, and the smart contract account would basically hold it in escrow. And again, it can only follow the rules that are set in the code within the account, right? So if the contract reads, hey, we achieved our goal of $10,000, time hasn't run out yet, it automatically sends it to the wallet of the team, right? And now they have their funds. But because, again, the contract is not controlled by anything other than the code, if the money was sitting in the contract account and the goal was never met, right, by the time that was set by that original team, then that would trigger the contract to send back the funds to all of the original wallets. And so the smart contract is what's now connecting these individuals who need the funding, right, with those that are willing and able to provide the funds. And this basically mimics exactly what GoFundMe is doing, but it does so in a completely trustless way, right, with no third party being involved. And so these are all screenshots from a very good video, which I'll put in the description. And here, just kind of showing some of the other examples of where smart contracts can be utilized. And there's already actually tons of different smart contract applications in Ethereum and other chains that are facilitating loans, right, of different crypto assets. Insurance payouts, they can be fully automated by feeding in some type of data into a smart contract so that it can trigger a payment to a specific wallet based on something happening, either something breaking or some type of event. I know an example of where this is being applied to is crop insurance, so automated payments based on weather events. And there's really such a large amount of use cases, right, where this type of real smart contract technology is being applied, right? And I will talk about some real projects, right, of how it's actually being applied a little bit later. But this is probably a good time to stop and just kind of, kind of harp on something like this is really what separates Ethereum from something like Bitcoin, right? Because this is all something that you technically could do on Bitcoin blockchain in terms of using smart contracts. But because Bitcoin was never designed to be this blockchain that allowed you to build all these different protocols and applications on top of it, Ethereum was able to bring about a blockchain that was specifically designed, right, to enhance these smart contracts. And this is why they call Ethereum a smart contract platform. And I think that this innovation is somewhat similar to when a language like JavaScript came out for the internet, since JavaScript essentially allowed developers to build these different types of new applications on top of the current internet technology and browser technology, right? And so I do think that they're going to end up being different stories, but JavaScript kind of serves as a good analogy, since Ethereum allows developers to use this new language Solidity, right, to build all these new kinds of applications that live on the technology of Ethereum blockchain, right? So I think what makes people so excited about something like Ethereum is that Ethereum allows developers to build smart contracts that other wallets in the network can interact with. And this is what actually makes way for the decentralized applications. And so decentralized applications, or dApps, they're internet applications on Ethereum, right, and other smart contract platforms that utilize these on-chain smart contracts and wallets. And so if you look here, this is a picture of the Ethereum ecosystem, and it's actually just a really small and probably old snapshot of the ecosystem. It's really just one of the first images that I found in DuckDuckGo. But it's a sample of just the different decentralized applications that live on Ethereum. Because developers have been building, they're still building tons of different applications. It's bringing a ton of different dApps into this ecosystem and a bunch of more users on the blockchain. And these dApps, they're also kind of, the word is pretty interchangeably used with protocols. So they mean the same thing, right? And a lot of these protocols or dApps, they actually have their own tokens as well, their own currencies that live within Ethereum. And so to explain how this ecosystem, right, has gotten so big, now I'm going to go into some actual use cases of these smart contracts, right? Because it's smart contracts that really make up this ecosystem, right? So I'll start talking mainly first, right, of how these Ethereum tokens exist, right, via smart contracts. And so Ethereum tokens are basically just different cryptocurrencies that exist within the Ethereum blockchain, right? And so basically these tokens are using a lot of the similar concepts of Namecoin, right, which I mentioned at the beginning of the video. So in a similar way that you could create these new currencies in the Bitcoin blockchain, you can create these new currencies within Ethereum, but you didn't have to, have them be backed by Ether, right? And so the developers, they were basically able to do this by creating a new smart contract account, right, that essentially serves as the central issuer of this new currency that you want to make. So it's almost like its own little ledger living within Ethereum, and where it can manage transactions on the tokens. It can keep a balance of the accounts that hold the token. So similar to our casino analogy, right, where the casino is this central issuer that's facilitating the transfer of these chip tokens that are backed by cash. In the in Ethereum, it's the smart contract account who is facilitating all of the trading of this new currency. But the smart contract account can also control other features of the currency, right? It can show you how many tokens exist, how they're being distributed to the different wallets in the blockchain. And this slide here is actually a snippet of code, and this is actually what the smart contract accounts look like, right? So developers, they put together this thing called ERC-20 standard, right? And this is basically a standard that tells developers, if you want to create a token on the Ethereum blockchain in a safe way, use this ERC-20 standard, right? Use this lines of code. And that's what all these Ethereum tokens that exist are, right? And you can see some of the functions or some of the things that this smart contract account can do, where it's able to return the total supply. So, how many tokens exist. You're able to transfer and send different tokens to other addresses. And this is how you're able to really quickly just create your own currency in Ethereum, right? And it's the reason why you see so many tokens in the cryptocurrency space, because it's really not that hard to just copy and paste this code and just, put out one of these smart contracts on the Ethereum chain. All of a sudden you have a new currency that you can trade. And people even made these different user interfaces to let even non-developers build and create their own tokens. So you can see here, create a total supply, put a name to it, create your own cool little symbol. And when you hit create token, this essentially creates a new contract account that manages the transferring and the distribution of this currency. But what's interesting is that because these smart contract accounts are on this public ledger, anyone can go in and look at the actual code that the developer put together, right? So you can do your due diligence on these different currencies and Ethereum tokens that are out there. And so this screenshot here just shows the recent transactions of this Chainlink ERC-20 token. So I can actually take the smart contract address, right, the wallet address of this smart contract of this ERC-20 token, and I can search it up on any blockchain reader. This is a screenshot taken from etherscan.io. And because the smart contract keeps track of all the transfers of the tokens, you can actually look up the history on all the transactions for the token. And you can see more than that. You can see the balance of all the wallets that hold the token. You can maybe see what the wallet that created the token is doing. And this is a really big part of on-chain analytics, which is kind of an up-and-coming industry within crypto, where people are basically on these different blockchain readers looking at the different activity and coming up with different metrics and kind of measurements that they can come up with to try and quantify some of the activity that is going on with some of these tokens. And they do that, just to kind of make, help investors or different token holders make different decisions, right, on based on what's going on with on the activity with these tokens. So that was a quick tidbit on Ethereum tokens, and I really only spoke about ERC-20s, right, which are tokens on Ethereum, but these are currencies, right, where these tokens are can be exchanged one-to-one, right? So meaning that they're fungible. So these are not what are referred to as the NFTs, right, or non-fungible tokens, where non-fungible means that there only exists one of these types of tokens, right? So NFTs, because of how unique and cool they are, require a whole video, right, which I will do next. So if you want more info on NFTs, I will put some cool links in the description just to kind of get some initial understanding of it. And I'll put some more content on that later on. But I mainly just wanted to call out how what I was just talking about are these Ethereum ERC-20 tokens and how they're different from something like a true NFT, right, or a non-fungible token. So to keep harping on smart contracts, what they can do, now I want to talk some more about how they're kind of being applied today with real projects, real applications. And so, I spoke about how easy it was to create these new currencies on the Ethereum blockchain using these smart contracts. Now it's more talking about applications that people are actually using, right, and how these protocols are utilizing the smart contracts. So the first one I want to mention is Ethereum name service, which is actually what inspired the name cryptofern.eth. And to understand Ethereum name service, it helps to understand what domain name service is, since it's basically trying to copy what domain name service is doing in the current internet. So domain name service is basically like the phone book of devices that live in the current internet, right? So phone books, they attach names to phone numbers. The DNS registry, they attach names to IP addresses. So the computers that operate the internet, they only know how to speak to each other with these IP address numbers, right? So, but when we humans, when we're using the internet, we can't remember all these super long numbers when we're surfing the web. So rather than putting in these IP addresses, we just use these easy domain names like google.com or facebook.com. And that's what we use to surf the web, right? But what's going on in the background, right, when one of us types in google or facebook.com, some other DNS server is kind of coming in between our request and first, going to verify, it checks in the database to see where it is that you're trying to go based on the domain name that you provided, and then it takes you to those machines, to that server, right? The issue, right, with this current approach in the internet is that there are these third-party companies, right, that are essentially managing these different databases, right, that store the different names to IP addresses. But they're also the ones that are hosting this code that's doing all the translating, all the redirecting, right, while we're surfing the web. And this kind of goes back to the trust that's needed to be placed in these third parties to facilitate all of this identity management, right, within the internet. And so Ethereum name service attempts to do the very same thing as DNS, where DNS is this phone book of IP addresses for the internet. ENS is the phone book of wallet addresses for the blockchain internet. And so the idea is pretty simple, and that's that instead of this phone book of addresses, right, being managed by different, companies where you can set up your own domain name with one company, but there's a bunch of different companies that you can do it with. Instead, it's managed as a smart contract that you can only add to, right? So people can basically only register new names on this Ethereum name service, and they cannot delete or modify any of the names. And so ENS allows you to attach a name to a wallet address, right? And instead of you having .com, you have .eth. And this is really handy because right now, if I wanted to send some Ether to my buddy John Doe, I'd have to copy and paste this super long address of letters and numbers. Wallet addresses, the public addresses of wallets are in this like long hash, right? And I wouldn't even try to write it down letter by letter, right? And I definitely probably won't remember it, right? I won't remember John Doe's or anybody else's long wallet address. So by having these ENS equivalents, I can easily share my wallet address, and it makes it much easier for us to interact in these blockchain systems. But the biggest details is that there's no third party that is storing or upkeeping this registry of names, right? It's all stored as a smart contract that lives on the blockchain. And so anyone can go in and verify, validate the information in this registry, but nobody can go in and change what's been added to the database. And the idea is that the smart contracts living in the blockchain, they're not only doing the managing and the storing of the phone book, but they're also doing the redirecting, the translating of the names to the wallet addresses with the machines that are actually running the blockchain internet, right? And what this ends up doing is that it decentralizes this, current identity service that DNS is currently doing in the internet, right? Of helping the machines and humans interact better over the web. And this is all, again, with Ethereum name service being managed by these smart contracts that are deployed to the blockchain. And in the future, if there really is a large majority of the population that's actually interacting on the new blockchain internet, we have to utilize a service like this, right? Because it just makes it so much easier for us when we're interacting on the blockchain. And so that's a brief summary really on ENS, since there's really a ton more info on Ethereum name service. You can use ENS to set up a wallet to accept any kind of cryptocurrency, so not just Ether or any of the Ethereum tokens, any cryptocurrency. So I highly encourage you to learn more about ENS and ENS DAO, which stands for Decentralized Autonomous Organization, which is the entity that backs the Ethereum name servers. DAOs are a really cool part of the whole crypto space, and because of time, I won't be able to go into it in this video, but I will, or in that much detail, but I will post some cool articles and links in the description. And so this is the first example I gave of a decentralized application within Ethereum that's being used a lot, right? The next project that I want to highlight in this video is Uniswap, which is one of the big time players in this decentralized finance space of crypto. So within blockchain ecosystems, there exist these things called decentralized exchanges. And these decentralized exchanges, they're dApps that utilize smart contract accounts to facilitate the swapping and trading of different crypto assets. So Uniswap and Curve here to the left, these are some really big protocols that are seeing some of the most trading volume, and they operate under this automated market maker model. So a market maker essentially facilitates a trade or an exchange of assets between two parties, right? And they sit in between buyers and sellers to basically ensure that there is always liquidity for these different buyers and sellers. And I think most people who have ever invested or traded any type of securities, they're probably pretty familiar with the order book model, which is a way that market makers, just one automated market maker way to connect buyers and sellers by basically keeping track of all these different orders that are being placed, right? So centralized exchanges like Coinbase, or even places like Charles Schwab or Fidelity, these other exchanges, they have all this liquidity of different assets, right? Whether it be crypto assets or just regular securities. And they essentially take orders to buy or sell different assets. And these centralized exchanges, they're the main and only source of liquidity that is connecting these buyers and sellers, right? So for Coinbase's case, they have this central source of different assets, right, by buying a bunch of different cryptocurrencies. And we're able to then buy and sell all these different assets basically using Coinbase's liquidity. And Coinbase is incentivized to do this because they earn fees from everyone's trading volume. So the Uniswap model is very similar to Coinbase, but in a way whether it's an exchange, right, of different crypto assets, but it's very different from the traditional Coinbase or centralized exchange model for two main reasons. The first one is the automated market maker model that Uniswap uses is very different, right? Because instead of taking orders and connecting buyers and sellers, Uniswap is basically facilitating a market request to swap a specific asset pair, right? And the second difference is that it's able to do this by using a decentralized source of liquidity. And so how Uniswap is able to do this is by creating these different smart contract accounts that serve as liquidity pools. And so these pools basically work by having different liquidity providers, so just all their wallets on the blockchain, putting down their assets into this smart contract so that people who want to swap between these assets have the liquidity to do so, right? So in this example, a user can use this liquidity pool to trade some Ether for a Uniswap token, right? And this smart contract will allow a wallet to make this swap. And so there's wallets that are giving their assets to the smart contract, right? So that there exists this liquidity for this specific asset pair. And then there's wallets that are asking the smart contract to facilitate a swap of these assets. And the people that are asking for a swap, they have to pay a small fee to these different liquidity providers, right? So these liquidity providers, they're incentivized to provide these assets because of the fees that are generated from the swapping volume. So again, similar to an exchange like Coinbase. And the Uniswap protocol is essentially just a collection of these different smart contract liquidity pools that help facilitate the swapping of a number of different cryptocurrencies that live within Ethereum, right? And there's tons of different crypto assets that are on this protocol and a crazy amount of volume as well. Just like looking at this table, it shows how the swapping that was executed on these smart contracts in Q4 of 2021 was north of $200 billion. And that's just like from pure volume, right? And that volume was able to generate somewhere around over almost $500 million in revenue from processing fees. So that's not chump change, right? There's a crazy amount of on-chain trading going on. And Uniswap is really just one of the protocols that are part of this kind of whole decentralized finance space, or DeFi. And DeFi is really just a small piece of the dApp ecosystem of Ethereum, right? But it is a really cool space, and some other projects that I think are important to highlight, just don't have the time to get into. Aave. Aave is a money market protocol where it's basically connecting lenders and borrowers with smart contracts. MakerDAO is an algorithmic stablecoin. So stablecoin is a token on the blockchain that is basically pegged to the US dollar. And this specific stablecoin is backed by an over collateralized treasury of different crypto assets. So meaning that there's certain percentage more crypto assets than there are stable coins in circulation, because the stable coin is backed by this treasury. And this treasury and stable coin is all managed by smart contracts on Ethereum, right? There's no third party managing it. And Curve is another cool DeFi protocol that sees some of the highest volume specifically for these stable coins swapping and trading. And so, in my opinion, if you're in finance, I think this is a must for you to get into, to start learning about, because there's some pretty cool stuff that people have been building in this space. And one thing that I think is important to mention, one of the big critiques that this whole DeFi space gets is, well, they call themselves decentralized finance, but they're not actually decentralized, because they make the comparison to something like Bitcoin, which I think is a truly decentralized system, from top to bottom. And so the critique is, okay, well, Uniswap and any of these other dApps on Ethereum, they're ran by companies so they're centralized. And I think that is true, right? But I think that's more of a gotcha argument than anything else, because it's kind of discrediting, some of what these new types of entities are doing, right? So yes, the infrastructure that's running the whole application may not be fully decentralized, right? Because Uniswap is hosting and making the user interfaces, and they have a lot of influence on what goes on with the smart contracts in the protocol. But the idea of a peer-to-peer lending and borrowing protocol, a peer-to-peer trading protocol where there's no centralized source of liquidity, I think is extremely significant, right? And these protocols also share that blockchain feature of being open and permissionless, right? So if you have a wallet, you have gas fees, you can interact with these other smart contracts. And another significant part is that there's no capital requirement, right? If you have $20,000 or you have $20, you can get in on this ability to lend out your assets to earn yield, right? So basically what I think is going on is that it's giving everyone the opportunity to get in on this, basically what all these banks and decentralized exchanges are doing, where they're deploying their capital to earn yield and make more money, right? So I think it just really gives full open access to everyone to use these types of unique financial services and kind of financial instruments almost. So now that I've introduced some of the projects within Ethereum, I think it's probably a good time to introduce the concept of Web 3.0. And realistically, I think what you are getting is just my interpretation of what Web 3.0 is, right? I think that because there's so many definitions, right, that people have for Web 3.0, it's just a bunch of confusion as to what this thing really is. So I'll try and give you cryptofern's take on what Web 3.0 is, and of course, I'm going to try and provide just some context, because I think it definitely can help to understand what Web 3.0 can be, kind of maybe going through all the different iterations of the web. And so early on, the very first form of the internet, what we'll call Web 1.0, was defined by this read-only web, right? So it means that we were basically just sending and receiving information back and forth for many years, and we were able to read, store information, and send it, and we were able to read this info. And what Web 2.0 is usually defined by is this read and write feature, where the users of the internet were now able to write on top of what developers were already building and putting together, right? And so this allowed users to actually generate new content. So things like YouTube, other social networks that we're all a part of, these are basically platforms where different users can write and generate their own content. And that is really what led to a huge boom in activity in the internet, right? In particular, in regards to content. And so the idea that people believe is that with this new blockchain infrastructure, we can now build a new iteration of the internet that incorporates a lot of the same Web 2.0 stuff, but with some new features, right? And the main feature that blockchains are able to allow is this ability to provide ownership to digital assets. So this introduces the latest feature of web, right, where there exists a public internet where we can also own digital assets, right? And this is what blockchain technology in general made possible, because in the way that it allowed the ability to transfer value digitally, right, over the internet using cryptocurrencies, and doing this without needing to rely on the different third parties or gatekeepers that are currently facilitating all the digital value transactions that we have. It's almost as if the current internet that we have is really is Web 2.5, right? Since we can own things digitally, right? But all these things are essentially living inside these private networks that we're then given access to, right? So we don't necessarily own, right, with quotations, the money in our bank, since it really just exists in their network that they own and manage. So our accounts can be frozen by these banks whenever they want, and then we no longer have access to our money, right? In similar ways, things like Fortnite skins, I think, are a good example in terms of these are things that you buy, right? And you can buy them and your account can own them, but only within the actual Fortnite network. And these assets that you have digitally, that you quote unquote own digitally, it's not like that has like that much liquidity to it, because you can't really trade it in the internet, unless maybe you trade over your entire account, right? Since that's really who ends up owning it, right? And so Web 3.0 has this vision of ownership of digital assets on these completely open networks, right? And if I had to give kind of like a real or further interpretation of Web 3.0, I think Web 3.0 has to include two things, and that's wallets and smart contracts, right? Wallets are what allow the ability for any individual to connect to a network and gain access to these different blockchains that make this own feature of Web 3.0 possible. And there's no sign up, right? There's no KYC or know your customer process, that's needed to get a wallet. It's completely open and permissionless. And our wallets, they actually, they're important for Web 3.0 because they end up serving as our identity to all these different blockchain networks, right? And the different applications or protocols that live within these networks, the wallets can also serve as the identity for that. And this is something that's really different from, what currently exists in Web 2.0, right? In the current internet, because we don't have something that can serve as our identity for every application that we use, we have to create a unique account for each network that we're a part of, right? And sometimes, out of convenience, some websites allow us to use like a Facebook account or a Google account, and that can serve as our key or identity to a lot of these applications. But usually we end up creating, a unique account, right? And so this is Web 2.0, right? If you're ever using crypto applications and they ask you for an email, right, or some type of sign-in information, then it's not Web 3.0, right? It's, if anything, it's some company that's kind of attempting to simulate the Web 3.0 experience in some way that, you're familiar with, since not a lot of people like using wallets just yet. And so rather than being in this world where we essentially have different accounts, right, that live on a bunch of these different networks, whether it's Facebook network, Google network, Apple network, the vision of Web 3.0 is that everyone can be connected to this global blockchain metaverse, right, that is completely permissionless, which is what the internet is currently like, right? The internet really is this open protocol, but it's really only like the actual networks that we've become a part of that have become permissioned, have become censored, right? And these different networks like Google and Facebook, they actually are able to monetize a lot of the activity that goes on, in terms of if we are able to, out of convenience, use the Facebook sign in or Google, our Google identity with these different accounts, they're monetizing that different activity that we generate from using these different sites, giving them to marketers or different companies, right? And so the wallets, right, they bring in this unique feature to the internet of being able to now safely and securely own digital assets, as well as also being able to serve as identity in the Web 3.0 world. So that's the first piece, right? The second piece is the smart contracts, right? To me, Web 3.0 has to involve real smart contracts on real blockchains, because this is what attempts to remove the trust that is currently placed, on different third parties to facilitate some types of digital transactions, right? And so the vision is that Web 3.0, it can be this new internet that anyone can access with a wallet and do all these kind of interesting things with these other smart contract accounts that live on the internet, right? And I think that this can really help decentralize the current internet, right? Because it does give the ability for anyone to create applications that are at least more decentralized than the current internet that we have. And I'm going to bring our friend Karen again, because this is the main counter argument that some of these smart contract platforms are getting, right? About that they're actually not truly decentralized. And I do, think that there is validity to this argument, right? Because there's a lot of pushback on these central entities that back these decentralized applications, and some of these applications are backed by central entities more than others, if that makes sense. But I also think that people just get too caught up in the words that are being used, right? And they're not really focusing on what can actually be built using this smart contract technology. If we need to come up with a new semi-decentralized word just to be less confusing, and so be it. But a lot of the new stuff that is coming out is remarkable, and I think it's objectively empowering, individuals, right, and disempowering, large corporations and those types of groups, right. Right now the script is totally being written, right. So a lot of these are all new ideas that are being tried, and I think, especially in regards to DAOs, right? DAOs, very much could have a chance to change the way that, we're able to execute governance or make decisions as a wider collective, right? DAOs are essentially, they're trying to automate as many actions as possible that a collective can do by using smart contracts on the blockchain. So whether it be a company or a community, a DAO can make proposals on how the community or company should move forward. And the different wallets can vote on these proposals, and they can use the blockchain as proof of, what the real vote is. So it's really kind of trying to somehow remove the ability for someone within a collective to act in a kind of like a self-interested way, right? Or be a bad actor, do something that the whole collective does not agree with. But either way, this is still an entity of humans, right? That backs this DAO, and that's what people give the pushback. So it can always be subject to foul play, and crypto is by no means short of examples like that. But I do think that it is objectively a much better alternative to Web 2.0. I think it's become much clearer to some people, which is some of the things that are going around in the world today. And I myself am certainly a believer in Web 3.0. I do think that the space is really brand new, not only with the applications being built on top of it, but also in just like blockchain technology in general. So I definitely am super psyched to see, what's going to come in the next few years, just as more and more builders, more and more smart people just start coming into the space and build. And so I'm going to start now kind of wrapping things up on Ethereum. And again, hope that from this video, it's at least can become a little clear as to maybe, how something like Ethereum is different from something like Bitcoin, right? Ethereum at the end of the day was certainly inspired and made possible by something like the Bitcoin blockchain, but it by no means, I think, was intended to solve the same problem that Bitcoin attempted to solve, which in my last video, I claimed that it was trying to create a digital payment rail for cash with its own decentralized native currency in there, right? So I don't think Ethereum was trying to solve this problem. I think rather it was trying to solve the problem of how can we build a blockchain that we can easily build stuff on top of, right? And so I don't think that these two blockchains are actually competing with one another, but they're rather, they can coexist with one another. And so the way that I see it, there exist kind of these purely monetary networks that offer a digital payment rail for some type of currency, that's native to these networks. And that's what things like Bitcoin, Litecoin, Bitcoin Cash are. Litecoin and Bitcoin Cash, they were these blockchains that were trying to serve as kind of monetary network replacements for Bitcoin. They were by no means trying to compete with something like Ethereum, right? Since when Ethereum came out, it offered a new idea, right, of there being a blockchain that serves as a platform that can be used for all these new kinds of applications, almost like an app store. And these are the smart contract platforms, right? The smart contract platform is where all these tokenized assets can exist and all these decentralized applications that you can interact with. That's where they can be. And you must be on these different smart contract platforms to use all these different features. And Ethereum is by no means the only smart contract platform out there, right? Because so many people in crypto, they understand kind of how much potential exists in terms of overall volume and activity that can live in the internet of these different smart contract platforms. There's been tons of competition in this specific space, or what people also call the layer one space. And so different teams, different companies, they have stood up a bunch of these different smart contract platforms in the past almost kind of 10 years. And that's led to an already really big and a rapidly growing blockchain metaverse. And so when I think of the word metaverse, and I think people use metaverse for like the virtual reality stuff with Facebook, but I think especially in crypto, it usually refers to this potentially interconnected system of different blockchain internets, right? Where each network will have its own set of applications that is open to all of the wallets in this metaverse. And what you see here, like this slide of kind of huge amounts of different applications, is all the competition between these other smart contract platforms, where they're saying, hey, we're better than Ethereum because of X or Y, and usually it's because we're faster or cheaper, or maybe because we have some better or cooler applications on there. And this is one of kind of the major current narratives in crypto, right, as to what layer one is going to be the blockchain of the future. And these chains that have tons of users already using all the different dApps that are on these chains. So I do think, as more developers, they start building more applications, it's going to get more people, on these new internets, on this new quote unquote metaverse of different blockchain internets, creating more volume. And these internets right now, they're currently not compatible with one another. And I think that's something that is still being worked out in the space of how can this whole metaverse operate in unison, right? And so the stuff is certainly working so far. I think really time will tell if it will work forever. And for the sake of time, I'm not getting into these different smart contract platforms, but definitely encourage people to learn more about this L1 space, bro. These different smart contract platforms, what these different companies and groups are doing, because a lot of these layer ones are certainly backed by different entities, and groups. Some a lot more than others. But this is something that I think is what ends up separating these smart contract platforms from something like Bitcoin, right? And that's the fact that Bitcoin is so purely decentralized and the network of miners is so strong. These other networks that are out there, whether it be monetary networks or other smart contract platforms, I think they all have different levels of decentralization that they sacrifice in order to gain something else, right? Whether it be higher speed or cheaper to use. And they're doing that to basically kind of capture value in the market, right? And it very well could be that those kind of offsets end up kind of encouraging some type of adoption of a platform. But I do think that kind of as years go by, it's possible that the central groups that are kind of backing and holding many of these networks up can start to fizzle out, right? And not to say that there definitely won't be some ones that stay around and continue to operate, and provide genuine value in the market. I just think that the only networks that will survive in the very, very long term will be the ones that can survive without the entity that is actually backing the network. And in my opinion, again, no other network is more suited to do this than Bitcoin, right? Which is why I still, I think that Bitcoin can coexist with Ethereum and these other smart contract platforms out there. So if I try to imagine a world, right, or a scenario where these two blockchains are coexisting with one another, I can totally see Bitcoin blockchain, the whole Bitcoin network, having that main role as being like a decentralized currency for societies, right? From a network strength standpoint and kind of tokenomics, nothing is better than Bitcoin in terms of being able to be like a reserve cryptocurrency, right? And based on what I do know about Bitcoin, I don't believe that it can do what these smart contract platforms can potentially have, where we have so many different assets as tokens on these blockchains, and we have all these smart contracts that are being used for so many different things. And because of that, I think that we'll find a way to make these two types of chains work, right? And that Bitcoin and these different smart contract platforms are just going to continue to coexist and kind of finding their different niches in this whole economy and this whole space of crypto. And so Bitcoin, again, it can be this decentralized currency and payment rail that we use, but then there will be a gap that will be filled by these smart contracts and smart contract platforms. And I think that that's what's going to be able to allow this new internet with all these new, unique, open services that are predicated on minimizing trust. So I really do see this world where these two types of chains can live with one another. And again, my guess is that the network with the strongest foundation, right, with the strongest set of miners, strongest tokenomics of that native currency, that will be the one that sticks around the longest. So which ones those will be, I think would be really interesting to see unfold, right? And I think that is really kind of my closing thoughts on Ethereum, and these smart contract platforms, and how Bitcoin and them can live in the same world. I definitely left out a lot of information that I wanted to call out, in particular related to the miners, and the consensus methods for most smart contract platforms, including Ethereum, and how it relates to proof of stake. So proof of work and proof of stake is a huge argument within the whole crypto space. And again, wasn't able to get into it in this video just to not bore people to death, and it'd be super long. But I may put out some more content on that just because it is such an important topic. But I'll definitely put some more videos on that in the description. So appreciate you making it this far. I'll put another picture here of my buddy Charlie Munger. Misquoting him here, saying Ethereum is useless and has no value. I've genuinely heard that from people, and it was the same kind of thought that I had when I was a big crypto skeptic. But it really just wasn't until I started actually learning about all this new technology with the Ethereum virtual machine and the smart contracts that got me really fired up to learn more about this space. So that's what I'm trying to do with this video, just trying to put some good information out there that can hopefully explain things in some good ways that can encourage you to learn more. So if you like the video, like, comment, subscribe, do the whole thing, and thanks for watching.